Then when you get a sequence of a virus and it looks like a relative of a known nasty pathogen, just like we did with SARS, we found other coronaviruses in bats, a whole host of them. Some of them looked very similar to SARS. So we sequenced the spike protein, the protein that attaches to cells. Then I didn't do this work, but my colleagues in China did the work. You create pseudoparticles, you insert the spike proteins from those viruses, see if they bind to human cells. And each step of this, you move closer and closer to this virus could really become pathogenic in people. So you narrow down the field, you reduce the cost, and you end up with a small number of viruses. Viruses are. So if you want to find the next pandemic, you should do a lot of work in South America, where there are lots of bat species harboring lots of unknown viruses. You should also do a lot of work in Southeast Asia. So this becomes actually useful. So working with the USAID EPT PREDICT program and funding through NIAID to work on coronaviruses in China, we were able to test out this idea of predicting what the next emerging disease might be. So we've all heard of SARS. We know that SARS is carried by civets. Well, actually, the host of SARS-like viruses, the viruses that the SARS coronavirus emerged from, are bats. We discovered this a few years ago, published it. We found about 5 different viruses. You can see these ones in green. So we thought, okay, we've got an interesting set of viruses. It seems to be the origin of SARS. They're found in bats in China. It's a nice paper. We published it, I think, in Science. And, it was quite interesting. But then PREDICT came along, the USAID program, to discover new viruses in wildlife. And we worked in China to go out and do surveillance in other bat species and say, how many other SARS-like viruses are there? Is there something even closer to SARS? And sure enough, there was. And we've now found a very large diversity of SARS-like coronaviruses. Some are almost identical to SARS. In fact, there's one cave in Yunnan province that has every genetic element of the SARS coronavirus circulating in bats. And there are people out there who are hunting bats in that cave, eating them, people who live close by. And we're now doing surveillance of the people, and we've found using NIAID funding that actually there is potential of spillover into those people. We're starting to see some worrying signs in that part of the world. So here's a way to take the predictive side, go out and actually find evidence of a SARS-like virus spilling over into people, potentially. Then we started looking, where did they come from? And we went out to southern China and did surveillance of bats across southern China. And we've now found, after 6 or 7 years of doing this, over 100 new SARS-related coronaviruses, very close to SARS. Some of them get into human cells in the lab. Some of them can cause SARS disease in humanized mouse models and are untreatable with therapeutic monoclonals, and you can't vaccinate against them with the vaccine. So these are a clear and present danger. Yeah. We've even found people with antibodies in Yunnan to SARS-related coronaviruses, so there's a human exposure. Right. We're now doing surveillance. We're just beginning another 5 years of work to look at cohorts in southern China to say, well, how frequent does this spillover happen, and is it associated with disease? Because I expect, just like Nipah in Bangladesh, there are dozens and dozens of small spillovers going on the planet any one time, which we just never see. Sure. Yeah, they never amplify. There are a few cases, and they're just absorbed in the illness, the overall illness of the population, right? Now, you could say, so who cares? And that's one argument. But our strategy is any one of those could become pandemic. There's a lot of stochasticity in what happens then. Yeah. So if we look at all of them, understand patterns, try and reduce the number of spillover events, we've got, But if you're saying these are diverse coronaviruses and you can't vaccinate against them, there are no antivirals, what do we do? Well, so I think that coronaviruses are pretty good. I mean, you're a virologist, you know all this stuff, but you can manipulate them in the lab pretty easily. It's just spike protein drives a lot of what happens with the coronavirus, zoonotic risk. So you can get the sequence, you can build the protein, and we work with Ralph Barrick at UNC to do this. Insert it into a backbone of another virus, and do some work in the lab. So you can get more predictive when you find a sequence. You've got this diversity. Now, the logical progression for vaccines is if you're going to develop a vaccine for SARS, people are going to use pandemic SARS as
sure.
But let's try and insert some of these other related and get a better vaccine.
And I guess also knowledge of what's there. If you see something emerging, it give it a head start on making a vaccine or a therapeutic.
That's true, and better knowledge of where they are as well, so that you can put your money into these clinics that matter.